The following presentation is going to be about volatile solute, Raoult's law, and colligative properties of freezing point, depression, and boiling point elevation. First, I am going to talk about volatile solute. Volatile solute has a tendency in forming a vapor at a certain temperature in the solution. Such solute, when adding a solvent, will increase vapor pressure of the solution and will raise the boiling point of the solution. We can see from the graph here, the pink graph represents the vapor pressure of pure solvent, and the blue graph represents the vapor pressure of the solution after adding a volatile solid. We could get the change of boiling point from the graph at the area of the red circle, while the change of the freezing point from the graph at the area of the green circle. We can see that there is a drop of solution's freezing point and a rise in its boiling point. Next is the Raoult's law. The vapor pressure of a solution of a non-volatile solid is equal to the vapor pressure of the pure solvent at that temperature multiplied by its mole fraction. X is the mole fraction of compound A, which could be get by dividing moles of solvent by the moles of the solvent plus the solution, while P0 is the normal vapor pressure of a pure A at that temperature. When the liquid and vapor are at equilibrium, the pressure of the vapor above the liquid is the vapor pressure. Now I am going to talk about elevation of boiling point and depression of freezing point. Referring back to the graph that we just see, when we add a volatile solid to a solution, the boiling point increases and freezing point decreases. We could get the change of boiling point by the equation delta T equals I, which is the Van Hoff vector, times K, which is the molar boiling point elevation constant, times M, which is the molality of solution. Similar for the freezing point change, delta T equals I times K times molality. Using these two equations, we could also be able to determine the molar mass if the change in temperature is given. If the change is given, we would then be able to get the value of molality as both I and K are constants. Then use the equation of molality, mole of solid over kilograms of solvent, and we find the mole of solid, then divide the mass of solid by this value. We get the molar mass of the solid. To know the value of I, the Van Hoff factor, we will need to know the number of ions that could be split from the compound. For example, sodium chloride has an I value of 2. Calcium chloride has an I value of 3, while for most of the molecules, they all have an I value of 1.